And now let's look at how we can convert an angle from radians to degrees. So let's say I want to convert theta equals 3 pi over 5 to degrees. So this angle as given has a pi associated with that, and so having pi, or just simply a number, a fractions without the degrees indication, those are in radians. And so now converting to degrees, here's what we can do. The formula set as a reminder, d equals the radians divided by pi and multiply with 180. And so, or you can think of that as the same formula as r times 180 over pi. Commonly, I would go with this way of arranging it, so that would give me a much easier the cancellation of pi, and you will see in the example throughout how I'm doing the example. So in this case, our degree is going to be from where you're given 3 pi over 5 in radians. We're going to multiply with 180 and divide it by pi. And so now immediately pi cancel with the pi as a common factor, and 5 also has a common factor with 8, with a 180. So it gives me 3 times which equals 108. Now the final angle here is degrees. So the angle 3 pi over 5 is 108 degrees. In a different example, let's convert the angle from the angle 2.52 to degrees. And so this angle expression right here, even though it doesn't have the pi, but it's already meant having the pi multiplied with some other value and to get the 2.52. So just to clarify that 2.52 is already a radian unit. So we're just simply going to use the formula. The degrees here is going to be found by the given angle in radians. We're dividing by pi, and we're multiplying that with 180 degrees. And so in a situation like this, we are forced to use decimal again, so keep in mind that 2.52 already had a pi multiple in it, and so dividing pi away, and pi in this case we must use the commonly 3.14 value, and your calculator actually has the exact value of pi. So in these days, as long as you are using those TI 83 or 84 calculator, you can get the exact approximate, much better approximate. The calculation comes out being the angle 144 in 2 decimals, 0.39 degrees. And here we can convert from two pi over 3 angle. This is in radians, and we want to convert that to degrees. So notice again that 2 pi over 3 is a common angle. And so one option of your work is you can just look through your unit circle and find where 2 pi over 3 is, and this is a positive angle. So 2 pi over 3 in degrees is say 120 degrees angle. So we found a solution. But I would like to also stay with the formula solution so that everybody can get comfortable with using the formula. So now in degrees, the formula says, now in this problem right here, it's easier to so that we can just write the radian separately and multiply with as a separate fraction 180 over pi right here. And so my given angle 2 pi over 3, I am going to multiply with 180 over pi, and this will cancel my pi easily. So now it gives me a, and notice the 3 is also canceled with a common factor, and that leaves me a 60 degrees here. So this altogether is giving me 120 degrees. And there are times that our angle is a negative angle again. In radians, so negative pi over 5. We can once again calculate the degrees, convert that angle into degrees by using the formula, the radians given, multiply with 180 over pi. And so the only difference now is that radian is given in as a negative radians. So we have negative pi over 5 multiplying with 180 divided by 5. And so that now cancel out of 5, cancel out of pi, cancel out of 5. We're looking at the angle being negative 36 degrees.